College Algebra, Review Chapter, Section 5, Factoring Polynomials. What is Objective 1? Well, these objectives are going to sort of go all together, I think, because I don't always take it in the same order as our textbook. So I'm going to change, I guess I'm going to put all these factoring, the sum or difference of two squares, the sum or difference of two cubes, perfect squares, second degree polynomial quadratics. So all of these really just going to be factoring techniques. Oh gosh, I can't even spell techniques. Techniques. Okay, 1, 2, 3, 4, 5. We're going to call this all. So, what are the techniques? Well, I put them in order like this so that I can remember. The first thing you should try to do is look for one factor, the common factor. Look at all the different terms and see if you can pull out a common factor. If that is not available, you start thinking of these two terms at a time. And there is the difference of two squares. Or the sum or difference of two cubes. Now, that happens a lot, and those are not too hard once you get used to the patterns. 3, this is the hard one. This is for trinomials. And you can break them up. I think it's worth looking at. If you have ax squared plus bx plus c, you can think of it in two situations where a is equal to 1, so you really don't see a coefficient there, and when a is not equal to 1. That a is the one that makes it either easy when it's 1, or a lot harder it seems when it's not 1. So we'll look at those as a couple of examples. And then there's 4 terms, which uses grouping. If you get up to 4 terms, then it's usually don't have some nice, I guess, these techniques to use. Grouping them and finding a common factor from that can be helpful. But those are the big ones, and those are the ones that we're going to start looking at. And they are, I guess, probably all we'll do for this textbook, but you got to be able to do this. So, our first one, if we start looking at factoring, let's see if I can write this down for you. So, if I have 60x cubed y plus 23, let's do not 23, let's do 20 xy cubed minus 15 x squared y squared. Okay. When you look at this, you see 3 terms, and that's the way to look at this. So you could say, let's skip down to do trinomials, but the first thing you should look for is a common factor. Is there a number common to all 3 of these? Can I pull that number out? Well, 60 is too big. 20 might work because it goes to 60, but that's too big. Maybe it's 15. So if I pull out a 15 and let me leave some room for other stuff, the 60 becomes a 4. The 20 becomes, oh man, 15 won't work for that. So maybe I have to just go with 5. And if you make a mistake, it's not bad. You just have to make sure that you check this thing out, I guess. So 5 into 60, let's see, that goes 12 times then. 5 into 20 goes 4 times, and 5 into 15 is a negative 3 times because of that negative 15. Okay, do all of these have an x? Yes, they do. But I want to pull out as many x's as possible, but it looks like just one x is all I can pull out from each. So if I pull out an x, that leaves 2 here. That one's gone, and that leaves one of them here. Okay. And now, how about y's? The same thing. You want to pull out as many as you can, but I can only pull out one of them. That gets rid of this one. So it's plus, gets rid of one of those, leaving 2. And it gets rid of one of those, leaving 1. So I pulled out as much stuff as I can. This 5xy is a factor because it's multiplied by this other factor, the 12x squared plus 4y squared minus 3xy. Now you might say, can I factor this thing? And we'll get to something like that, I guess, and to be able to check it out when we get to the trinomials. But I've sort of run out of space for this. But you shouldn't stop until you're sure that this can no longer be factored, and this other factor can it no longer be factored. I guess I'm really not sure. I just picked this off the top of my head. We may have to come back and look at that. So let's go on to the next page. What about 36x squared minus 9? Well, is there something common to both? Let's see, I can pull out a 9 from each one, right? What's left over? Well, a 4x squared minus 1. So am I done? Well, the 9 is okay, but this is 2 terms. So you look at your list and say, see, for 2 terms, difference in 2 squares, sum or difference in 2 cubes. Well, this is certainly a square. Is this 1 a square? The nice thing about a 1 is you can square it and it won't change its value. So yes, this is the difference of 2 squares. Now you got to be a little careful because you got to include the 4 here. So it's really 2x squared minus 1 squared. And if you need 4 steps, this is one way to get it. Rewrite it. So here's the 9, and then you got a pattern. Remember, it's the sum and the difference. It's 2x plus 1 and 2x minus 1. So the pattern for the difference of 2 squares, box squared minus triangle squared. And I want to make sure you understand it does not work for the sum of 2 squares. You need complex numbers for that. It factors into 2 binomials, the sum and the difference of the square roots. So it's nice to write those as squares so you don't have that 4 get all messed up. Don't put the 4 there, it's got to be the square root. So this is the difference of 2 squares. Okay, what's next? How about 25x squared plus 10x plus 1? Okay. Now to start, is there anything common to all 3 of these? Well, that 1 sort of throws some wrench into the works for that. So there's no common factor. Look for that first. If this can be factored, then there's many techniques. I sort of like the guess and check, because eventually you'll get good at this. First of all, not sure about this 25. It could be 1 times 25. It could be 5 times 5. Those are the only 2 choices. But the 1, I'm sure, the only way to get a positive 1 is when you have 1 times 1, and both of these signs must be the same. How do you know what's the sign? Well, if this is plus for the 3rd term, they're both the same sign, and this must be the sign, the middle term, the 2nd term. So both of these have to be pluses. And you know if this is going to factor, that's got to be. There's no other choices. But now you got choices for this. 1 times 25, 1x times 25, or times, 25x, or 5x times 5x. And that is usually my first choice because they usually don't do 25. And since you need a 10 here, 5 and 5 is 10. Let's see if this works. You always need to check this when you think you're done. Let me write it here so I can show you that this is the Louisiana School for Math, Science, and the Arts, and you can see art in all kinds of things. So 5x times 5x is the 25x. 1 times 1 is the 1. The inner product is 5x. The outer product is also 5x, which gives us a positive 10x, which is this middle term. Now, if you look at this very closely, you can see this is a face of a guy who's got a crew cut, wearing sunglasses. Here's his eyebrows. Here's his nose. He's got a little mustache and a smile and a goatee. Anyway, is that written factored? Well, yes, but it's sort of nice to take this one more step. 5x plus 1 squared. This is what we call a perfect square, a perfect trinomial square, because it'll factor into the same two factors, so you can write it as that factor squared. Will I take off if you don't write that? No, I don't think so, unless in the directions I say write all multiple factors as a power or something like that. But this certainly is 4 steps. How about the next one? Let's see, 3x squared minus 10x minus 8. Now I've chosen, I guess, these that have this leading coefficient because that's the more problematic situation. If this 3 weren't here, that first part of your two binomials would just be x times x. So that's the way you can be sure of that. So let's do this. So we get 4 steps listed here. So the only way to get a 3x squared is 3x times x. That's the only way. Now this negative for the third terms means that these have to be opposite signs. Do I know it's plus or minus? It could be minus and plus. The nice thing is, when you check it, if you get the wrong sign for this middle term, you just switch these two signs and you'll have the right answer. You have to have the right number here, of course. So, the factors of 8, we can have 1 times 8, and 2 times 4, and that's pretty much it. But I always try the middle one first. 1 times 8, let's see. Because we're going to have to subtract and get 10, I'm going to say it's 2 and 4. Oops. 2 and 4. But I need to check it. This is my 3x squared. This is my negative 8. Remember, that's the crew cut and his eyebrows. He's wearing sunglasses. This is a positive 2x. And this is a negative 12x, which gives me a negative 10x. So my guess was right. So the answer, 3x plus 2 and x minus 4. When you're all done, make sure you're all done. Take a look at those two factors. Can I factor those anymore? No. But don't stop until you look and say, I can't do any more to this. Okay. Let me see if I can go to the next screen. Okay. How about 5 plus 11x minus 16x squared? Now, this is sort of a trick one because it's got a negative over here. They've written it in increasing powers, but that's okay because of the negative. We know there's only one way to get 5. 1 times 5. That's positive 5. Now, this third term, once again, is negative, so it can be opposite signs. I'm going to put it this way. The factors of 16 are 4 and 4. And that's usually what I try. But we got to put an x with this also. the 4x and the 4x. So we get 5, that's up there. We get a negative 16x squared. Usually do those just to make sure I didn't make any silly mistakes. Here's a positive 20x, and here is a negative 4x, which is 16x. Uh-oh, that's not right. I want 11x. Does that mean this is prime? No, there's too many more choices here. Not only is 16 1 times 16, it could be 2 times 8, and it could be 4 times 4. So we've tried this one. How about the 2 and the 8? Well, in order to do this, we'd need to start again. 1, 5, plus, minus. So I'm going to do, if I do a 2 here, it would be 10. And negative 8, well, that's not 11 either. So is it 1 times 16? Let's see. If I do a 16 here, that's really, really big. But if I do the 1 here, I want x. And the 16x here, then I still get the 5. Still get the negative 16x squared. Here's a positive 5x. And then here is a negative 16x, which gives me a negative 11x. Oh man, it's almost right. I need a positive 11x. So what do? Switch these two signs. So your final answer, 1 minus x and 5 plus 16x. Now, if you're looking at these and saying, boy, I saw that like 10 steps ago, you must not be very smart. Remember, I went 4 steps, first of all. And if you saw it, that's fine. Just make sure you have 4 steps. Write down the picture of this guy with his goatee and mustache. Okay, one last one here. Suppose we've got x to the 4th plus x cubed plus x and plus 1. Uh-oh, 4 terms. Well, 4 terms leads us to this idea of grouping. And there are many ways to group it. First 2 and then second 2. First and third and second and fourth. Or maybe the first and fourth and the second and the third. Usually I start with the first 2 and the second 2. Once you have those grouped, then the next step is to take each of those groups and factor out a common factor. For this first one, I can pull out an x cubed. What's left? X plus 1. And we can divide this, right? Take x to the 4th divided by x cubed. That's really what you're doing when you factor. You're telling it what you need to multiply back in there so you can divide. X cubed over x cubed is 1. But I can't factor anything out of here, can I? Well, remember, you need something, so don't forget the 1 that's always there. And this is what you want to see for grouping. You want to see one of those factors in the groups that's the same. Because now this is one group, and this is another group, and those two groups have a factor in common, x plus 1. What's left? The x cubed plus 1. Now, if you forgot that 1, you just say x cubed, and that isn't right. You'd have to make sure you multiply this back to get all 4 of those terms. Are we done? No. Because 1 can be a cube, we have the sum of 2 cubes. So we need the x plus 1, and then what is the pattern for cubes? If you remember, plus or minus, that box cubed plus or minus triangle cubed is box plus or minus triangle times the box squared minus plus the box triangle plus the triangle squared. So once you pull out this x plus 1, then you square the first, x squared, opposite sign, minus. The product, 1 times x is just x, plus always square the second, 1. And I guess you can finally write this as 1 plus x squared times all this. You might say, well, is this trinomial? Is this something we could factor? You can try, but I've never found one from any textbook that factors after you use this sum or difference of two cubes. So, since I've run out of room, I guess we could say this is going to be x plus 1 squared times x squared minus x plus 1. Takes some practice. If you're not good at it, you need to get good. It's going to be a useful tool, and there'll be no time in your mathematical life that you don't sometime need factoring. So, do your best. Practice, practice, practice. We'll see you in the next section.